Okay, this is section 11.7, adding and subtracting rational expressions with different denominators. Now you've already added and subtracted rational expressions when they had the same denominator. And then we just talked about how to rewrite a fraction to have common denominators. So the first thing that we need to do when you have these fractions, we have three fractions here being added, but they have different denominators. So the first thing you're going to need to do is you're going to factor each denominator. And as you can see that 5 here in this last one, this is a prime number, so it can't be factored. 3 is prime, it can't be factored, but 15's not. 15 can be factored into 3 times 5. All right, so we want to factor those denominators, which is what I've done down here below. All right, and then after you factor the denominators, then you need to find that least common denominator. We just talked about that, right? So we're going to determine which is the least common denominator. Well, they have factors of 5 and 3, and the most that any one of them lists is one of each. So our LCD then is going to be 3 times 5, which is 15. And now you're going to take these three fractions and you're going to rewrite them to have a common denominator, which is what we just did in the earlier section. So we're going to rewrite them to have the LCD of common LCD. All right. Well, this one here already was 15, so we don't need to do anything. But this one here, in order to make 15, we had to multiply by 5, which means now we're going to multiply by 5 over 5. And this one here, to make 15, we had to multiply by 3, which means now we're going to multiply by 3 over 3 to rewrite our fractions. And so we go ahead and multiply across. X times 5 is 5x, and 3x times 3 is 9x. And you're putting that all over your common LCD, which is 15. And now that all these fractions have a common factor, then now you can go ahead and add them like you did in the previously two sections. All right, so what would be next is we're going to combine the numerators by adding or subtracting as indicated over the thing. So basically we're going to take 2x plus 5x plus 9x, which gives us 16x all over 15. And then the next step what you would do is you always want to see if you can reduce. So you would cancel any common factors. This is the process of reducing your fraction. Well, in this case, there isn't any common factors, and so it can't be reduced. Therefore, since we didn't cancel any other factors, there's nothing to set to 0, and there's no excluded values. So basically, these three steps do not apply to this particular problem. Let's look at another one. All right, so here we have two fractions, and the first thing we're going to do, they have different denominators. So what? We're going to factor what? Each denominator. Well, if you look at the first denominator, this can't be factored, it's prime. And this one cannot be factored, it's prime. So since they're both prime, then our LCD is going to be both of those multiplied together. And so that's our LCD, right? Then we're going to rewrite the rational expressions with that LCD. So that's what I've done here. Notice that this one, the first one, has the x plus 1, so it's missing the x minus 3, which is why I multiplied this by x minus 3. This one is missing the x plus 1, so that's why I multiplied this by x plus 1, x plus 1. After we've rewritten that expression, and so we're gonna simplify these, but it says just go ahead and rewrite the rational expression all over the LCD. So I've just put everything that's on top here, all right, all over the LCD. And before we can go any farther, we need to combine the numerators over by adding or subtracting. But first of all, we've got to do our order of operations. In other words, simplifying what's on top. So watch what happens here. We got to take 3 times x gives us our 3x, and 3 times a negative 9 gives us a negative 9, and 2 times x gives us 2x, and 2 times 1 gives us 2. So that's how I ended up with this here, and now we can add like terms. So 3x plus 2x is 5x, and a negative 9 plus 2 is a negative 7. So we have simplified. And next thing that we're going to do then is we're going to cancel out any common factors. Well, in this particular case, they don't have any common factors. Therefore, again, we're not doing these last 3 steps. That would be your answer right there. All right, now here we have 3 fractions. Again, they do not have a common denominator, so we're going to factor each denominator. Well, this one here, the x minus 1 is prime. It doesn't factor. And the x plus 1, it's prime. It does not factor. But this x squared minus 1 does factor. It's a difference of squares. And so it factors to be x plus 1, x minus 1. And now we're going to find our LCD. Our LCD is going to be one of each type of factor, which is x plus 1, x minus 1, and that they're only listed 1 each time. And now we have our LCD. And so now we're going to rewrite our fraction, right, all over that with the LCD. Well, this one already has the LCD. So on the first fraction, there's nothing to change. On the second fraction, this one is missing the x minus 1. So that's why here I have multiplied that second fraction by x minus 1 over x minus 1. And this one in the LCD is missing the x plus 1, which is why I've multiplied by x plus 1, x plus 1 on that third fraction. And then what I've gone and done is I went ahead, I had to simplify here on the numerators before I can combine and the like terms. So here I'm going to take x times x, which gives me x squared, and x times a negative 1, which gave me a negative x, and 3 times x gave me 3x, and 3 times 1 gives me 3x. And now I'm going to add like terms. I'm going to start with looking at the highest power. So here's my highest power, x squared. It's the only one, so I'm going to end up with x squared. And then here I took the 10x minus x is 9x, and 9x plus 3x is 12x. So that's how I got the 12x. And then I took my constants, 8 plus 3 is 11. And so now I have simplified, and now I want to cancel out any common factors. Well, remember, canceling out common factors, what you're doing is basically what you're saying to yourself is, can this fraction be reduced, right? If they have a common factor, they can be reduced. Well, the denominator is already factored, but the numerator is not. So you're going to have to factor that numerator. And when you factor it, you get x plus 1, x plus 11, or x plus 11 and x plus 1. And so now that we have factored that, we now can see, do they have any common factors in the numerator and denominator? In this case, they both have an x plus 1, so we're canceling that out, which leaves us with a final answer of x plus 11 over x minus 1. But remember, we've got to do this step 6. All right, step 6 is where you take whatever you factored out, or canceled out, excuse me, in the denominator, right? And you're going to set it equal to 0 and solve. And in this case, we find out that x, therefore, cannot be a negative 1. And so you have to write that as an excluded value. So this now here is your final answer. Let's try another one. All right, here we have 2 fractions. They don't have a common denominator at the moment. If you look at them, the only thing that's different is their signs, right? So when you do that, you can make them have a common denominator by factoring out a negative 1. But before I do that, I'm going to go ahead to help you see this. All I did is change the order. I put the negative x first and the plus 1 last. And so now it's real obvious that you can see the difference between these two, right, is the sign. So next step, I'm just going to factor out a -1 on that second fraction. So think about that. -1 times x is still a negative x, and negative times a -1 is still a positive 1. I haven't really changed the value any. All right. Now we have the x minus 1, x minus 1. The only thing that's different here is this -1. Well, I can take this negative sign and I can put it up on top. It won't matter. And that's what I've done in this step here. And you think, well, how can you do that? Well, think about that. What if I had a -2 divided by 3? Can I also write that as 2 divided by -3? Or isn't that the same thing if writing it as a -2/3? So either way is okay. So me moving this negative sign up here in this particular case is all right. So then that leaves us with, the same common LCD. And so we have 5 plus a -3, which is 2. And we ended up with 2 divided by x minus 1. Again, we did not have to cancel any common factors, set anything equal to 0, so we didn't have to do these last 3 steps. That would be your final answer. Now here's another scenario. It's a fraction, and then they're adding 2 whole numbers. Well, remember, you can put your whole numbers over 1. 3 over 1 is still the same thing as 3, right? And I can combine the 2x plus 3 over 1 because they have the same common denominator 1, right? So that's all I've done there. Now let's find our LCD. In this case, it's going to be x minus 1, because 1 times anything is anything, right? So we have the x minus 1. That 1 became invisible. This one already has the LCD, so I'm not going to change the first fraction, but this one needs to have an x minus 1. So that's why, again, I have multiplied x minus 1 in the numerator and the denominator to rewrite that. All right, so now we have rewritten the fractions, or we rewrote them all over that common denominator. And we want to be able to combine now the numerators, but before we do that, we have to apply the FOIL method here. Before we can simplify, we have to apply that FOIL method to this. So we know that 2x times x is 2x squared, and 3 times a -1 is 3. And if you do your middle term check, you're going to end up with a positive x. So when you apply that FOIL. All right. And now we've put everything all over the LCD, and now you can reduce. So remember, we're going to end up with 2x squared. This x plus x became 2x, and we brought down the -3. So right now we have just did step 4 where we were combining them. And now we're ready to cancel common factors. So you have to look at the numerator. The denominator is already factored. Can this trinomial be factored? And you could test it out. You could say 2x squared plus 2x minus 3. Well, what if I made this 2x plus 1 times x minus 3? And you do your check step and you find out that doesn't work. So what if I made this 3 and 1? Again, you do your middle term check step and you find out it doesn't work. So no matter what combination you get, this is not going to factor nicely at all. Now remember, before when we had something that didn't factor nicely, we used that quadratic formula. And if you had found out what A equals, B equals, C equals, and you plugged it into that quadratic formula, you would have got something like x equals 1 plus or minus square root of 7 over 2. Well, you don't have to do that. Right now, when we're canceling common factors, we're just finding anything that factors nicely. And so this one here does not factor nicely at all. All right? It doesn't factor nicely. So at this point, this would be your answer then. You don't have to go any further. All right, now here we are subtracting instead of adding. And we have a minus here, minus a negative x. Well, if I had something like 2 minus a negative 4, isn't that the same thing as 2 plus 4? Well, here what you have is you have this fraction minus this negative x over x plus 2. So this can become plus, just like this one became plus. So that's what I'm going to do in this next step. Okay, in other words, a negative times a negative is positive. All right, it changed the signs. All right, so from there then we want to factor the denominators, and we want to see, does it have a common denominator? Well, this one is prime and this one is prime, so our LCD is going to be one of both of them. We're going to then rewrite the fraction. This one was missing the x plus 2, right? So that's where I got my x plus 2 times x plus 2. The second fraction is missing the x minus 4. So that's why I multiply by x minus 4 over x minus 4. Then you have to distribute, right? This 4 times 4x, and this 4 times 2. Distribute to get, well, I just put everything over each other, and then now I'm distributing, right? The 4 times the x, 4 times the 2 gives me the 4x. Same thing, x times x is x squared, and x times the negative 4 is negative 4x. And now I'm going to simplify. So we know we're going to end up with x squared, but what is 4x minus 4x? Well, that's 0, so that actually cancels out, and we end up with just x squared plus 8. And you want to ask yourself, can I reduce, right? We're right here. Well, does x squared plus 8 factor? No, it does not factor at all. So it won't reduce. So that is your final answer. Here you have 3 fractions. One's being subtracted, one's being added. This is still the same process. You're going to factor each denominator. This denominator is prime, this one's prime. This one is a difference of squares that factors into being x plus 3 times x minus 3, right? So our LCD is going to be x plus 3, x minus 3. Now we're going to rewrite our fractions. This one already has the LCD, so we're not going to have to change anything in that last fraction. This one needs to have the x minus 3, and this one needs to have the x plus 3. So that is why we are multiplying by that in the numerator and the denominator. So again, this here gives you x and a negative 3. Distributing this gives you, remember, it's a minus sign here, right? So it's actually a negative 1 times x, which is a negative x, and then a negative 1 times a positive 3, which is a negative 3. So make sure that you realize that that is the same thing, because you can think of this as plus minus, right? So you're distributing that negative sign out. It's real easy to get off on your signs. Now we're going to simplify. The x minus x cancels out. A negative 3 times a negative 3 is going to give you a negative 6, and of course you're left with a 2x. And now we're here at step 5. Can this fraction be reduced? Oops. Can it be reduced? For some reason, when I touch the screen, it wants to move forward. Well, you have to factor the numerator, and the numerator has a common GCF of 2, so I factored out a 2 here. And now I can go ahead and cancel anything that is in the top and the bottom, which is the x minus 3. And we're left with 2 divided by x plus 3. We have to take what we've canceled here and do step 6 and find out what x cannot be. In this case, x cannot be 3. So this is your final answer.